If you are new to the channel, then subscribe the channel and press the bell icon for further notification. Okay students, so welcome you all to this new topic that we will be starting here, that is trigonometry, which we will solve in 3 or 4 parts. So these are the part 1, 2 and 3 and 4. In first part we will be talking about ratios, compound, multiple and submultiple. Second we will talk about trigonometry ratio. Third will be properties of triangle. Fourth one we will do little later after we complete the function, then we will come to inverse again. So okay, then today we will be solving, first we will take part 1, we will complete part 1 for both advanced and intermediate and advanced level. Then we will go to part 2, again we will convert all other 2 modules, basic, intermediate and advanced. Then we will come to part 3, similar fashion. Part 4 we will do it later. Okay, then let's start today basic discussions on part 1. Okay, we are at trigonometry part 1. Part 1 we will be discussing trigonometry ratios, compound angle, multiple and submultiple angle. So we'll start from very basics. We'll start from class 10 onwards. What concept you have till now, we'll just refresh little bit. Any misconception if you have, you just remove all those misconceptions before you move further. So what is angle? The angle is generated by rotating an ray. You will rotate a ray from a point, about a point. This is the point O. You are rotating, suppose OA is a ray and you are rotating it, and you are rotating it to OB position. So that is known as final position. This is initial position. This is known as vertex against whom you are moving the ray, or around whom you are moving the ray. When the rotation, you rotate anti-clockwise direction or counter-clockwise direction. Your clock moves in this direction. So if you rotate in anti-clockwise direction, then the angle will take positive, and if you take in clockwise direction, then it is negative. So generally these are the signs that will represent the angle. Theta, alpha, gamma, or A, B, C capital letters. These are, with these symbols we represent the angle. So what are the different types of measurements and different methods of measuring the angle? There are 3 different methods. One is sexagesimal system, one is centesimal system, one is circular system. So in sexagesimal system you have one right angle. One right angle, you know, the right angle means if the angle they are perpendicular to each other, we say this is right angle. So in sexagesimal system, one right angle is equal to 90 degree, or the symbol of degree is this one. 1 degree equal to 60 minute, or 1 minute equal to 60 seconds. Second symbol is double dash. These minutes and seconds are different to your minutes and seconds in your time, that is in hour. So these are different. In centesimal system, similarly one right angle. This angle in centesimal system we will write it as 100 grade, or we will symbol it as 100 G in the superscript. So again, one gradient equal to 100 minutes and 1 minute equal to 100 seconds. These minute seconds are different to these minute seconds, because these are 2 different systems. So don't get confused between both these minutes and seconds are not same. Okay, this one I think you know. Circular system, this one also you might have known, which unit is radian. So here the idea is, and it is very familiar in our engineering also, this type of measurements in radian measurement. What advantage we will see. The angle subtended by the center of a circle with an arc equal to its length of its radius is called 1 radian. Means suppose you have a circle of r radius. So if you cut a arc of same length of radius, suppose this is 5 centimeters. So you cut a arc of 5 centimeter. This length arc. So the both are same length, then the angle it subtend would become 1 radian. That is the definition of 1 radian. So if the length of the arc is r, then the radian is 1 radian. So if for 90 degree, what should be the length of this arc? Because total length is 2 pi r. So it is divided into 4 parts. So one part will be 2 pi r by 4. So for r length it is 1 radian. So for 2 pi r by 4, how much radian it will be? Simple unitary methods. R1 will be 1 by r. For this one will be divided by r. So r get cancelled, you will get pi by 2 radian. So that's why your 90 degree becomes pi by 2 radian. In pi by 4 it is, if you divide both sides by 2, so it is become 45. Similarly pi becomes 180, 2 pi becomes 360, because it is a complete rotation 2 pi, where pi is an hour 3.14 approximated to 22 by 7. So what is the advantage here? Because the angle now, so if you see, angle is now converted into some length. So there is a relation between length and angle. So instead of drawing, so this length, because length is distance, so you can keep the angle in x-axis if you want to plot it. You will see this plot of this trigonometry function in intermediate level, where we can keep this angle in x-axis, and if we move along the x-axis, suppose if I moving the distance, if I increasing my distance, so the angle will automatically increase, because if it is r, then it is 1 radian. If it is this much, then so if you're moving little bit more and more around this circle, your angle is also moving. So the angle and the linear movement, they are correlated using this radian. So that's why radian is very powerful or very useful in our engineering. Okay, for now you leave it. This is the relation, how we will find the relation between, how we will convert into degree, because we are familiar with degree, everything you have done in degree. So how to convert from degree to radian using this relation, or whatever, pi is equal to 180 also you can consider. So this is the relation. It is not the value of pi is equal to 180. This is the relation between radian symbol is C. This is the conversion from radian to degree. Value of pi is always 3.14. So what is the trigonometric angle? So trigonometric angle is nothing but, this is same angle, but here you will fix a line. So this is my initial line, that is, suppose this horizontal line, flat line in this direction, this is my initial line. So whatever angle I will say, I will take reference from this point, because otherwise there will be no standard. So if I say 30 degree, one can say 30 degree from here to here, one can say 30 degree from here to here. So there will be no standard of representation. So that's why it is standardized as, we will always represent my angle with this initial position. So with this initial position, what is the position of the ray? So suppose the ray is here, so I will say it is 30 degree from, so if I say 30 degree, then you will understand, okay, it is from initial condition, it is 30 degree. Automatically you will draw a reference, because this is my reference, and here you will draw 30 degree. If you don't have this reference, then you don't know where your ray will be. So that's why it is standardized. It is, we will always give answer of my angle from this initial condition. If it is anti-clockwise direction, so it is plus. I can say same ray with clockwise direction also. So then it will be minus 330 degree. You can see total is 360, so this much is 350. So this line can be represented by plus 30 also, minus 330 also. So both way we can represent these lines. So that's why the angle, my angle in trigonometric angle, can vary from minus infinity to infinity. You should not stop it here. Suppose I am rotating here 360, then I can rotate one more time. So 720 will land me here. If someone says 720 degree, that means I will land here. Again I will come to this position. Someone say me 750 degree, then I will land here. 750 degree, that means basically 30 degree position only. So my angle, you can keep rotating. How many times? As long as you are not tired, you rotate. You start rotating and you move. And as long as you are not tired, so you can go up to infinity. Similarly, you can rotate in different direction also, you can go minus infinity. So now your angle can become plus infinity to minus infinity. So from here your difference started. Class 10 you have done up to 0 to 90 degree. So here you are leaving the boundary now. Because you are going to higher classes, so your dreams also gets higher. So your theta is also get more exposure. It is now exposed more. So you will get more thetas. Until now it was limited to 0 to 90. So now as you get more exposure, your theta also gets more exposure. As you grow up, you can think your theta is also growing up. Okay. Now if I come to trigonometric ratios, what is trigonometric ratio? You have already seen 6 ratios: sine, cos, tan, cot, cosec, cosec, all these things. These are nothing but the ratios of the sides of a right angle triangle. You have a right angle triangle, you can draw right angle triangle in this way also, you can draw right angle triangle in this way also. Class 10 there was no problem. Both were, if it is theta, then the opposite of this one, which one is height? This is height. Opposite of angle becomes height. If I look from this side, if this is my theta, then this becomes height. If this is my theta, then which one is height? This is my height. This becomes base and this becomes hypotenuse. So it is not that always this will be height. Because I am looking from this side, so this becomes my base, this becomes, if I look from this side, you say your face is from this side, that means this is your base. You are staying at here and you are looking this side. So this becomes height. So from what orientation, because if I change this both, this orientation changes. So from where you are looking, that makes your height different. So okay. So now class 10 it was okay, in both directions you can draw and all your values were positive, and you remembered also sine 30 equal to half. All these tables are, so from where this table is coming, you draw, okay, you know sine 30 equal to half, because you know sine 30, how you have calculated, you remembered it, I guess. You can also prove it. You take a protector from your home, from your geometry box, you draw a 30 degree line, you can draw a 30 degree line and draw a perpendicular from this side, this side. You can draw this right angle triangle, you measure it. Suppose it is whatever measure you get, whatever, suppose you got it 5 centimeter. So you will get that, you will see that automatically this hypotenuse is 10 centimeter. So the ratio is, because height by hypotenuse is sine, you will always get half. So from here these ratios are coming. It is not arbitrary, this is the proof you can think of. So that's why it is 5 by 10. Always you go little further, if it becomes 6, then it will automatically become 12. So this ratio remains same because these are all similar triangles. So in case of right angle triangle, these ratios remain fixed, so that's why these are standardized at angle. Okay, what I was telling, so you can draw triangle in this shape also, triangle in this shape also, but now because my reference is this, so my theta should be because I am talking class 10, you are talking about only, because I told you my trigonometric angle starts from here. So class 10 you starts from 0 degree. So if you stay this line, this is 0. If you move from this line, if you come this line, this is 90 degree. But here we will, from now onwards, we will try to write it in pi, that is in radian. So it will be pi by 2 line, you can say, and this is become your 180 degree, because if you move now it is 180 degree, so we will write it pi. If you move little further, it will be 270 degree. Here it will write 3 pi by 2. If you move little further, it is 2 pi. So this is one complete rotation. If you rotate complete, you will find like this. So for class 10 you are having only this zone. This was in your class 10 only, between 0 to 90 degree. You don't go beyond this. So your right angle triangle will be something like this, because it is your theta. So your right angle triangle will look like this. This is, suppose this is x, this is y, because in terms of coordinate I am writing, and this is my hypotenuse distance between these 2 points, and r is nothing but under root x square plus y square. You can see it is Pythagoras theorem. So your r remains always positive. Now as you move along, your triangle, right angle triangle shifts. So let me see this one. So this is known as first quadrant. So for class 10 it was only first quadrant for you. Now it becomes 4 different quadrant. First quadrant, second, third, fourth. So first is between 0 to 90, 90 to 180 second, 180 to 270, or pi to 3 pi by 2 third, 3 pi by 2 2 pi is your fourth quadrant. Now let me see. In first quadrant your x is positive, this is positive x, this is because this side is positive, this height is also, we take normal coordinate geometry, this is positive, this is positive, 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 your r we always take positive. So your sin theta is height by hypotenuse, it is positive. So all your cosine, sine full form is sine, not sine, sine is short form. Cosine is complementary to sine, that's why it is cosine, short form is cos. Tan full form is tangent, it is short. Cotangent, complementary to tangent, that's why cot. Secant, sec. Sec is short form, actual name is secant. Cosecant, cosec is short form, so cosecant. So all this formula I guess you know, and because your all x, y, r, all are 3 positive, so all values you got class 10, your table, you remember table, all your values are positive values. So now you come to second quadrant. Now how I will draw in second quadrant? Second quadrant, if I want to draw same triangle, so I have drawn the same triangle, the triangle that I drawn in first quadrant, so I have drawn here. So it is the same triangle I am drawing in second quadrant. So this is my angle, but I cannot say this is my angle because I have to say from here, so this becomes my angle. Now you see your angle becomes more than 90 degree but less than pi, so it becomes in second quadrant. Now you see your x is now negative, y is positive. So if your x is negative, y positive, r is always positive because r is the distance. R is this one, under root x square plus y square, so you are always considering positive this one, positive root. So r is always positive. Now if you take sine, sine will be y by r, y is positive, so that's why sine positive. Sine positive means cosec is also positive because cosec is r by y. Now if you take cos, what will be cos? X by r, because x is negative, so cos becomes negative here. Cos negative, then sec also negative. Tan is y by x, because x is negative, so tan also get negative. So only sine and cosec is positive. So we write sine only, cosec will, wherever sine positive, cosec will automatically come, because cosec is nothing but the shadow of sine only. It is 1 by reciprocal law. So in terms of plus minus, whatever sine takes, cosec will automatically take. Now you come to third quadrant. Now if I want to draw the triangle, same triangle in third quadrant, so this is my theta, but I cannot say this is theta, I have to say from here. So if I am saying from here, so it is between pi and 3 pi by 2, so it is in third quadrant. Again you say here x is negative, y is negative, so sine will be minus y by r, so negative. Cos minus x by r, negative. Tan, because this is my angle, you see this is my angle, so this becomes height. So what is tan? Tan is this by this, so minus y by minus x, so tan becomes positive here because minus minus get cancelled, so cot is also positive. So this is fourth quadrant. So this is fourth quadrant, means in fourth quadrant you have, now here you have this triangle, so this is, so from here you have to say, So from here you have to see, if you see from here, this becomes your theta. So it cross 3 pi by 2 between 2 pi. So this becomes my fourth quadrant. Now here you say x is positive, here x is positive, y is negative, but r is always positive. So if you take sine here, minus y by x, so sine is negative. Cos x by r, cos is positive. Tan minus y by x, so tan is negative. So all these things are being considered, and it is written in general format now. So this is written all sine, tan, cos. I am not writing cosec, cot and sec, because wherever sine positive, cosec will come, tan means cot will come, cos means sec. So these three are main, rest three are thus reciprocal. So you take reciprocal, and you can, if you know the property of sine, the reciprocal property will be the cosec property. That's it. Sine is positive, so reciprocal is positive, will be always positive. You can remember, there are lots of abbreviations are there to remember it. All sine, tan, cos, say all student take coffee. So this one you can remember, all student takes coffee. So with this, because this is first, second, then third, then we go to fourth. This way we move. So all student take coffee. You can remember in this format also. So I think you remember up to this much, you keep it. We will continue in next class. If you like the video, then press the like button and please give your valuable comments in the comment section.